I like to etch my own PC boards, and I just wanted to share how I do the exposure part of the board. It's a very simple process. So I take a piece of this copper clad board. This is typically what I buy. It's pre-sensitized for photo etching. So the PC board in here is a phenolic board, FR4 board with full copper on one or two sides. And then as UV light, well, you take the board out of the package in darkness, or in low light even works fine. And you peel off the protective covering layer. It's like a film off of the copper side, and then you would lay it down somewhere wherever you're going to expose it. And then you would take your mask and turn it the right way. There's an up and a top and a bottom, and you center it over the board. I like to pre-cut the board to size first. That's a little tricky to do, but I found I can do it in my wood shop on the table saw in low lighting. Not so low that it's unsafe, but low enough where it's not going to affect the copper. And I do it before I peel off the film. So I come to the exposure stage with this board cut to size. I peel the film off of the copper side, and I usually use a single-sided board. This one's an old bad one, but normally this is all copper. And then I put the mask on it, align it correctly, and then I take my UV exposure board and just put it over the circuit. And if I turn off the lights here, you can see that it is bright in terms of UV light. You can see the orange label over there. This is under UV is definitely orange. You can have all sorts of fun. Look around your house. You know, it's just like a black light. I've got these tools. These tools are great. The handles just glow in UV. These wrenches or pliers. So what I wanted to do is review the construction of this board. How do you get a board that has UV light that is, you know, quite big? This is probably 8 by 10 inches. And the other thing I forgot, was I put this, took it down like this, like I did. And I don't leave it like that because it's kind of not flat. So then I take a piece of this plate glass that has a broken corner that I just put electrical tape on to be safe. I take this glass and I carefully set it on to hold that down as a press. And then I put my UV exposure board over it. And by experiment I figured out how much time I need to expose the board. And I just use a kitchen timer to tell me when to stop. And I don't know what the time is off the top of my head, but it's probably 4 minutes, 5 minutes maybe. So on to what I want to talk about, which was this board which I made from scratch. And basically it is simply an array of LEDs, and this is a UV strip that you can buy online. It's an LED strip with UV lights and UV LEDs, and every time it needs to be connected together, you just kind of make a U jumper. So the red wire is plus and polarity matters, so plus would be on the bottom of this strip, and then the wire would take it around to the top of this strip. So if you take the strips and put them back the way they were cut, you can see how it positive negative flip back and forth. So you just jumper the ends like that all the way up, and they'll all be powered. These strips are cuttable on these copper pads. You can cut those in half, like I've done here on the last one. I've cut this one in half, so I can solder onto the next part that I didn't use. And you can hardwire your power supply for this. I use this connector that I bought for this to fit this plug that I had. And the power supply I use is this 12 volt, well, it's adjustable, but it's really a 12 volt power supply the way I have it switched here. I only use the 12 volts for this, and then I use the other voltages for other things around the house. And it is good for 1 amp. So there's no way this board takes an amp. And you can look at the manufacturer's specs for the strip you buy to see what the current will be per foot, per meter, per length, and then you can figure out how much current overall. So here I've got 2, 4, 6, 8, 10, I think 11 strips that are a foot long. I've got 11 feet of UV, so that's quite a few LEDs. 3, 6, 9, 12, 15 times 11, so 160 or so LEDs. And the reason I made it this size is because I did not imagine I would ever expose a board larger than this, larger than roughly 8 by 10. That's a really large PC board for anything I think I'll be doing in the future. So what is this? This is not a piece of cardboard or something temporary. This is actually a piece of Luan plywood. It's 1/4 inch thick. I tried to find a piece that was fairly level, or not level, fairly flat, and then I just drilled a hole for each dowel. And these dowels are the legs. These are just 1/4 inch dowels. I drilled the holes after I laid out the strips because I didn't know exactly where the wires, the jumper wires and the strips were going to go, so I just laid them out and then I just drilled holes where there was space. And that's basically it for this project. So I've made many boards with this, and I don't think I'll use it for anything else, but it's worked great. I guess the only other thing, these strips are self-adhesive, and until now I'd never pushed them back down again. It's probably been on there over a year. I did put latex paint, white latex paint on this side, more to help the strip adhere, because I didn't think the strip would adhere to the bare wood on the other side very well, like this. So this thing's worked out very well. It was easy to make. Didn't take 5 minutes, but it probably didn't take me probably 2 hours anyway. So you can make one for yourself, and if your wife has fingernail polish that is UV cure, she could use it too. She could stick her hand under there and cure it quite fast, probably compared to whatever is out there on the market, because there is so much light cast off by this many LEDs.